This lesson is triangle fundamentals. We're going to learn how to name triangles, talk about angles and their opposite sides, classify triangles, and then we'll do a little bit of algebra based on angle and side measures. So to name a triangle, triangles are named by using its vertices. Every triangle can be named in 6 different ways. You use the triangle symbol, followed by the 3 vertices. So the most basic way to do this one, you could go alphabetical and call it triangle ABC. The triangle symbol, and then the 3 points, always capital letters. But you can also name this in any other order. Triangle ACB, triangle BAC, triangle BCA, triangle CAB, or triangle CBA. All of those are correct names for this triangle. And when we're talking about triangles, we also need to worry about angles and their opposite sides. So, take for example angle A. Draw across the triangle to the opposite side, and that is segment BC. The side opposite to angle B, draw to the opposite side, and that's segment AC. And then the side opposite to angle C, draw to the opposite side, and that's segment AB. Notice also, the angle and the sides all use different letters. That's another way to keep track of things. Since I used A in angle A, I'm not going to use A in the segment name. And that works for angle B, segment AC, angle C, segment AB. So the angle and the opposite side all have 3 different letters. It works the same way in the other direction. The angle opposite to segment BC is angle A. Just draw to the angle on the other side of the triangle. The angle opposite to segment AC is angle B. And the angle opposite to segment AB is angle C. Once again, the segment uses B and C, the angle uses A. You'll use all 3 letters when you're doing sides and opposite angles. What about classifying triangles? You can classify them by their sides and by their angles. If a triangle has sides that are 3 different lengths, then it's called scaling. All 3 sides are different when it's scaling. If at least 2 sides are the same, then it's isosceles. In this triangle here, 2 sides are the same length, so it's isosceles. Notice it says at least 2 sides, so if all 3 sides are the same, it's isosceles as well. But even more specifically, if all 3 sides are the same, you also call it equilateral. So if all sides are different, it's scaling. If 2 are the same, it's isosceles. And if 3 are the same, it's equilateral and isosceles. What about angles? If all angles are acute angles, then it's an acute triangle. So all 3 angles would have a measure less than 90, then it's acute. If a triangle has one angle between 90 and 180, then it's obtuse. So if a triangle has one obtuse angle, then it's obtuse. And if a triangle has one right angle, then it's a right triangle. If all 3 angles are the same, and that means they would all have to be 60 degrees, then the triangle would be equiangular. And since all three of these angles are acute, it would also be an acute triangle. So let's learn some rules about triangles and then put them to work. The triangle sum theorem says that the sum of the interior angles in a triangle is 180. And we actually saw that already in this equiangular triangle. 60, 60, and 60 add up to 180. And every triangle has angle measures that add up to 180. The third angle theorem says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles have to be congruent as well. That makes sense, since the first two plus the third is 180, and the first two plus the third is 180. If the first two are the same, then the thirds have to be the same. We've already seen this. Each angle in an equiangular triangle is 60 degrees. In a right triangle, the acute angles are complementary, which makes sense, since all three add up to 180. If you have a right angle, that leaves 90, so the two acute ones have to add up to the other 90. One more corollary says there can be at most one right or obtuse angle in a triangle. You can't have two right angles, and you can't have two obtuse angles. Remember, the three angles have to add up to 180. If you have two right angles, you've already hit 180. What's the third angle going to be? And if you have two obtuse angles, you're going to be over 180. What could the third angle be? So it's impossible to have more than one. The exterior angle theorem says that the measure of the exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. The exterior angle occurs when you extend a side and you take that extension and measure the angle that goes to the next side. The remote interior angles are the two angles on the other end of the triangle. It's not going to be the one next to the exterior, it's going to be the other two. And the remote interior angles add up to equal the exterior angle. So the measure of angle ACD equals the measure of angle A plus the measure of angle B. And you can make equations substituting in and solving. So for example, if I have this and I'm looking for the measure of angle A, 3x minus 22 degrees is the exterior angle. 80 degrees and x degrees are the remote interiors. So I know that the exterior angle equals the sum of the remote interiors. Add up the remote interiors to equal the exteriors. I can solve this and then find the measure of angle A. Subtract x from each side. Add 22. Divide by 2. And x is 51. That's not the answer we want, though. We want the measure of angle A. So the measure of angle A, which is x, we'll substitute that in, and it's 51 degrees. Even though x and the measure of angle A were the same, sometimes this might have some other terms in it, and you would have to do some work with the 51. Just make sure. Sometimes they say, what's x? Sometimes they say, what's an angle measure? What's a segment measure? So be sure you answer the question. So you know your ways to name an angle, or to name a triangle, you know the types of triangles. Remember that the three angles of a triangle add up to 180. And remember that the exterior angle is the sum of the remote interior angles.